Go. This was the last section in Chapter 8, 8.6 assignment, and it was on vectors. And since you hadn't submitted that one yet, I was just guessing that maybe that was the worksheet that you wanted to work on together today. So I thought I'd just go over it with you, and if it's the wrong one, then that's okay. We'll meet again tomorrow. A vector is a quantity that has both length and direction. So here's an example. They usually draw them as, it looks kind of like a ray, an arrow. And this arrow has a certain length and it has a certain direction. We can see that it's pointing, I guess it would be pointing kind of to the east or to the right side of the page and a little bit up. And it also has a certain direction. We name these, usually we name them by the initial point and then also by the terminal point, which I wrote it wrong at first. It should be right at the very end of it. So let's call this W. We would have to name this then VW, vector VW. Sometimes they'll name it with a small letter on the vector, like maybe vector Y, but usually they'll name them by the initial point and the terminal point. So that's just a little bit of vocabulary about vectors. Next, let's look at how we would often write vectors in component form. The first part of a component form is this less than sign. It's a pointy bracket. And then you put the horizontal change, and then you put the comma, and then a vertical change, and then another pointy bracket. You use the greater than sign. So by change, I mean you find the initial point where it started, where there's no arrow, and then you just count how many units to the left or right did it move. That's the horizontal. And then you count how many units up or down did it go, and that's the vertical component. So here's an example. They've got a graph here, AB. This vector AB is drawn here. I'm going to make it a little bigger for us. And they want us to write it in component form. So we can see that A is the initial point because it doesn't have an arrow on it, and B is the terminal point. So we just have to figure out how far did it go from A to B. How far did to the right did it go? 1, 2, 3, looks like 3. And how far up did it go? So it started down here and it went up to here. So that's 1, 2, 3, 4. So the component form is 3, 4 with those pointy brackets. Use the less than and greater than sign on your keyboard, which are right above the space bar on mine and kind of to the right. And then for 7, they don't have a graph of 7, but we can see that it would start at 0, 0. That's the initial point, and the terminal point is at 9 over 9 and up 5. So here's the vector would go from 0, 0 to 9, 5, and then you have to write that in component form. So you have to figure, okay, how far did it go from the initial point? I'll color that purple here. How far did it go from the purple to the black dot? Well, we can see that it went over 9 units and up 5 units. So you'd put in 9, 5 for your component form. Do the same thing for number 8, except this time our initial point started at 1 for the horizontal and goes to 6, so you'll have to subtract. You'll take 6 minus 1 to get the horizontal form, and then the vertical part of the component form started at 2 and it went up to 6. So then you have to figure out what is 6 minus 2 and put in for the vertical. For number 9, same thing, but this time there's a graph. Number 10, you might get a negative for number 10. I'm not sure. It starts at -1, 2, and it goes all the way until you get to -10 for the horizontal. So yeah, it looks like you're going to have a negative horizontal. And number 11 is the same thing. So all of these are just rewriting them in component form, with the horizontal change being the first number and the vertical change being the second number. And you'll always, if they're written with the points, then you will be subtracting. You'll be taking -10 minus -1 That's the same as -9, and so on. Okay, so finish up those questions. Notice that I skipped 1 through 5 because they're easier to do when you're done with the rest of them. So if you're looking at your worksheet and saying, why aren't we doing these? Well, those would be better done at the end. I think I skipped that's 12, 13, 14. I think I just have them arranged in the wrong order. That's okay. Okay, so on 12, 13, and 14, they ask you to draw the vector and then find its magnitude. So we need to know what magnitude is. Magnitude is the length of a vector. That's all it is. It's the length of the vector. And we already know how to find these by using either Pythagorean theorem or the distance formula. The distance formula is you subtract the x-coordinates and square them, and you subtract the y-coordinates and square them, and then you take the square root of the whole thing. Oh, you add those two parts together, take the square root of the whole thing. Or you can just do the Pythagorean theorem. For example, number 12 says to draw the vector, and the vector component form is 5, 2. Now I'm going to start at the origin, and I'm going to make my horizontal distance be 5. 1, 2, 3, 4, 5. And the vertical is up 2. So I need to end at the point 5, 2. So I should have ended just slightly before that, but we'll call that 5, 2. And this should have an arrow on it. If you can draw the arrow, that's great. If you can't, that's okay. And now I just need to find the length of that segment. So you could use the Pythagorean theorem. You could just drop this straight down and make a right triangle. And this side would be 2, and this side would be 5. And then you go 2 squared plus 5 squared is equal to, I'll call this side d squared, and then solve that and find d. Or you can use the distance formula. The coordinate of this point, of course, is 0, 0 over here, and this point is 5, 2. So you're going to take 2 minus 0 squared and 5 minus 0 squared. So you're going to end up with the same thing. And then take the square root. Okay, in number 13, the component form is -4, -7. So the -4 means you're going to go -4 on the horizontal. Oh, these are going every 2 units, by the way. So there's -2, -4, but I also have to go down 7. So 4, 5, 6, 7. So about right there is the vector. My arrow is a little bit off too again. These are kind of small for me to draw with this mouse. But in any case, you have a, you can again use the Pythagorean theorem, or you can use the distance formula. I'll use the distance formula this time. Again, one of my coordinates is 0, 0, and the other coordinate is -4, -7. So the distance formula, it says to take x minus x and square it. So -4 minus 0 is -4, and I have to square that. And then take -7 minus 0 and square that, and then take the square root of the whole thing. So you just finish solving it, and you'll get your answer. Same thing on number 14. Now the next part is going to be finding the direction. Now this might be the toughest part of this assignment, because you have to use trig, you have to use tangent, which is why it's in this section, because we learned about tangent. So in this one, the direction is the angle. Oh, I should have went back to pointed that out. The direction of the vector is the angle it makes with the horizontal line. So we need to find the angle, so that's why we need to use tangent. So first we're going to draw the vector, and then we'll find that missing part. 4, 6. So we have to start at 0, 0, and we have to go over 4 on the horizontal and up 6. 2, 3, 4, 5, 6. 1, 2, 3, 4. I think it's right about there. And we're really looking for this angle in here. We could make a right triangle by drawing a line straight down. And we're looking for that angle. We know that the opposite side is 6, and we know that the adjacent side is 4. So the tangent of our angle is equal to the opposite side over the adjacent side, which means that the inverse tangent of 6/4, or I could simplify that to 3/2 if you wanted, is equal to the measure of our angle that we're looking for. So that'll be our answer. So then it's just a matter of getting your calculator out. This is the same as 1.5, so you take the inverse tan of 1.5, and that would give you angle A. And you do the same thing for each of these. Once you draw the vector, let's see, this one's 3, 2, then you can drop that line down and make a straight line so that you can make a right triangle. And then you're looking for the measure of this angle in here. And the opposite side is 2, and the hypotenuse is 3, so we're looking at the tangent of A is equal to 2/3, which means that the inverse tangent of 2/3 is equal to A. And then you use your calculator and find out what that angle is. All these angles will be between 0 and 90, so that's what you should check, that you get that. Okay, there's not much left on this. Equal vectors have the same magnitude in the same direction. They'll have the same slope. They'll have the same length. That's about all you need to know for that. And parallel vectors don't have to have the same length. They just basically need the same slope or the opposite slope, which is the same direction or the opposite direction. Those are parallel. And then the very last thing that we covered in this section is adding vectors numerically, and that is you just add the two horizontal components together and you add the vertical components together. So this would be -3 plus 5. -3 plus 5 is 2, and the vertical part would be 4 plus -2 would be 2. That's all there is to these. You just add the horizontal parts, and then you add the vertical parts, and you write them with the pointy brackets, the less than and greater than signs. There is a bonus section at the very end of the worksheet that you can skip. You don't have to do that part. I think we covered pretty much everything else on the worksheet, and we'll go over any other questions you have when we meet. Thank you very much, and have a great day.